So, by means of LAN, you connect all the devices in your home. So, the your home network is is an isolated network. That is, there is no existence of your home network outside your home. So, it is very local to your home. So, if you need to connect your home network to the rest of the world's network, you need internet, because internet connect different types of networks. Internet is a network of network. So by means of internet, you can connect the rest of the world's network. So to connect all the devices with each other, you can go by two options. You can either use wire, or you can connect by wireless. If you connect all the devices by means of wire, then your LAN will be called as wired local area network. If you connect all the devices of your LAN by means of wireless, that is wireless adapter, then the your local area network will be called as wireless local area network. That is the separate thing. And this section will solely discuss about this wired local area network. So the LAN market has several technologies such as Ethernet, token ring, token bus, FTTI, and ATM plans. But the Ethernet is the most dominant technology and widely used technology. The topic that will be discussed in these sections will be IEEE standard frame format, addressing Ethernet evolutions, standard Ethernet, fast Ethernet, Giga Ethernet, and 10 gigabit Ethernet. This is the IEEE standard for LANs. So there is a transmission medium, and above that transmission medium there is OSI layers. So Ethernet technology is very much different from the token ring technology and token bus technology. So the physical layer of Ethernet technology is very much different from the physical layer of the token ring technology. So depending upon the very lowest level, that is layer 1, the upper layer, that is data link layer, is dependent. So as the layer 1 is different in case of different technologies, so the upper layer must be different for different technologies. Say the upper layer of Ethernet, that is Ethernet MAC, will be very much different from the data link layer, or say token ring MAC, data link layer of the token ring, or say token ring MAC. And this is the Ethernet frame. This is the lower one, layer 1, that is physical layer, raw data. Okay, and this can vary from depending upon the data or packets. So the minimum payload is 46 and the maximum payload is 1500. So this is the everything that is one byte, and there so this take byte and then you take the least significant bit of byte 1. If the least significant bit of the byte 1 is 0, then this is unicast address. If the least significant bit of the byte 1 is 1, then this is the multicast address. One thing is to be noted that in case of broadcast, the whole first byte will be 1. So this is an example where 3 address is given and you have to say which kind of address it is. So there will be 12 hexadecimal digit and you take the of the first byte. So you take the second hexadecimal digit and take the last bit, or directly you take the second hexadecimal digit and calculate whether it is even or odd. If it is even, then the last bit or the least significant bit will always be 0. If the second hexadecimal digit is odd, then the least significant bit always be 1. So you just take the second hexadecimal digit and find out whether it is even or odd, and depending upon the answer you decide whether it is a unicast address or multicast address. And if the second hexadecimal digit is f, the address will be broadcast address, and if the second hexadecimal digit is even, then unicast address, and if the second hexadecimal digit is odd, then it will be unicast address. This is the thing that computer understand. Human is not familiar with the so large 48 bits number, so they express the thing by means of colon and hexadecimal digits. But actually this is the thing that computer understands, and the address is sent left to right by bit by bit, okay, or byte by byte also. First byte, then second byte. For each byte it is sent right to left. So this is the case. The whole address is sent from left to right. So same time, like opt time, random number, and number of attempts. So this is the algorithms. Okay, CSMSCD algorithms. So first station has a frame to send at k equal to 0. Then you check if channel is free. If true, then you go to the next step. Then done or collision is there. If no collision, then you go proceed on a step further. If you again detect the collision, if collision is not detected, then you send by means of a jumper and you increment the value k, and if k is 15 less than 15, then you go above and create a random number and wait tv second. Okay, if k is too much, that is greater than 15, then we abort the whole things. This is CSMSCD algorithms. Okay, the summary of the standard Ethernet implementation is that four kind of things. Okay, 10 base 5, 10 base 2, thick LAN, thin LAN, and 10 base T, and 10 base F, that is fiber. So 10 base 5 maximum length is 500 meters, and 10 base 2 maximum length is 185 meters, and in 10 base T there is UTP, untwisted pair. Okay, it is 100 meter up to 100 meter, and in case of a fiber that is 2000 meter. And if you if you use the thick coaxial cable, you need to place the repeater in every 500 meters, after every 500 meters, otherwise the signal will lost. So this is the actual picture of the 10 base 5 Ethernet, and to connect the Ethernet, the device with the Ethernet into tap, we need a tap. Okay, by means of tap you connect with the actual core materials. Okay, so in thick coaxial cable there is two core. There is inner core, that is pure solid, and there the output, and above that there will be a insulated thing, and above that there will be some thin kind of metals around. This is the picture of the thick coaxial cable, and this is the picture of the thin coaxial cable, and their unit is T. Okay, T. And in case of thick coaxial cable, you need tap. And this is untwisted pair, that is RJ45 connectors. Okay, UTP cables you have. Then in case of fibers, you have this kind of things. Okay, 10 base. Now in fast there is increase in speed. So in fast everything will be appended by an X. So there is 10 base F in standard Ethernet. So there will be 100 base, 100 is the speed. Okay, 100 is the speed. First it was 10 Mbps, then it became 100 Mbps in case of fast Ethernet. So this will be 100 bit base FX. X is the X is for the fast Ethernet. Okay, then shielded twisted pair STP, that is 100 base TX. Then unshielded twisted pair UTP, that is 100 base T4. This is a fast Ethernet things. Okay, Giga Ethernet, so you need 1 Gbps, so you write 1000 base SX, 1000 base LX, fiber long wave, 1000 base CX, and 1000 base P4. Full duplex mode of the gigabit Ethernet, there is no collision. Maximum length of the cable is determined by the signal attenuations in the cables. Gigabit Ethernet implementation. There is 1000 base SX shielded pair, shielded twisted pair, 1000 base LX long fiber cable, and 1000 base CX. And the maximum length is of 300 meter, 1000 meter, and 400 meter, 40,000 meter. Now the wireless LAN. So the first section we deal with wired LAN. Now it is wireless LAN. So how you can connect your LAN devices by means of wireless? There is some standardizations, that is IEEE 802.11 wireless LAN technologies, and it's incorporate the Bluetooth technologies. Okay, this is not Wi-Fi technology, and this is actually applicable for small LANs because Bluetooth range is not so big. Okay, so basic service set ad hoc network is there. Now access point is there. Now wired, by means of wired LAN you can connect the access point, but this access point, through this access point all devices are connected, the basic service set is connected wirelessly. This is a CSMA-CD collision detection algorithm in case of wireless LAN. This is the thing with CSMA-CA and NAP. This is the frame format, and this is the subfield in Fs. This is the control frame, RTS and CTS ACT. Subfield is the control frame. This RTS is 1011. Now CTS frame in CSMA-CD handshake can prevent the collision from hidden stations, and this is the use of handshaking to prevent the hidden station problem. First you send RTS, then CTS. This is the use of handshaking in exposed station problem. This is a piconet. Okay, frame format types. Now point to point ones, there will be 65K modems, TSL technology cable modems, T-lines, sonnets, and BPP, point to point connections. Okay, now this is by means of modem. This PCM wave go through this, and by means of telephone network it's go to the ISP servers. ADSL is an asymmetric communication technology designed for resident users, is is not suitable for business. Upstream and downstream bandwidth is divided like that. Okay, so in your, if you guys are familiar with broadband connection, then you can see that there is up speed, down speed. So the speed is divided, okay, for every different type of package. So if you buy 250 rupees package, then the downstream will be something, upstream will be something. If you buy 760 rupees package, then upstream will be something, downstream will be something. For that's so the total cable bandwidth is divided like that. Cable modem is there, is sonnet, right? Now switched one is by means of x.25 frame relay and ATM. There is marks and time division multiplexing is there, ATM marks, and by means of switch the endpoints is connected. It is architecture of ATM networks. Then the virtual circuit, use of layered technologies. Okay, IP protocol use AAL5 sublayers. ATM layers is there. They connect. Now connecting devices, repeater, bridge, and out. So layer 1 device is hub, layer 2 device is bridge, layer 3 device is router. Hub connect by means of only physical layer. Hub is a physical layer device, so it just sends the raw materials, raw data. A repeater forward every bit, has no filtering capacity. Repeater and hub is similar things. Okay. Bridge has a table, and it can make a decision about the source and destinations. The bridge does not change the physical address in the frame. So bridge knows that if one computer sends data to another computer, say computer 1 to computer 3 or computer 4, then bridge maintains a table, and in that table port number is written. Okay. So by means of that port number, it can easily transfer the packet rather sending the all packet to the all devices. But hub do these things. Hub send the packet all the devices, and device decide whether to keep the packet or drop the packet depending upon the destination address. Check. So this is the thing about learning bridge. Okay. So you see, first A, original address and port is given, then this goes to D. So after A sends a frame to D, port is updated, the table is updated. Okay, then the table is again updated, and you know the two ports now. Then again, if 2 sends a packet to A, then finally you got all the ports. Okay, and this can be done by means of advertisement technology. Okay, a router is a layer 3 device, physical layer, network layer and deal with. Okay, repeater bridge connects the different segments of the LAN. Router connects independent LANs or ones. That is, router can connect your home LANs with your school LANs with your college LANs, okay, or ones. So router is for internet. This is a network device. So there is a router based on the internet. It's connected to the internet, and from that router there is a bridge, and by means of bridge two LANs, different LANs is connected. The router can change the physical address in the packet. This is the third video. If you guys are really like my video, then like it and don't forget to subscribe my channel. Thank you.